Yes, sir. Good to go.
Thank you. Hello and good evening, everyone. My name is Girish and I am the Vice Chair of IEEE CEDA Bangalore chapter. I welcome you all to the EDA Toolsmith program. I thank all the participants for your interest and registering for this program. As you all know, the EDA tools are the backbone of VLSI industry. Designing today's complex integrated circuits is almost impossible without them. You might have used commercial EDA tools by Cadence, Synopsys, Siemens, and so on. While working with these tools, at some point in time, you might have wondered how these tools, EDA tools, actually work. In this series of lectures, you will learn specifically about compilers, and other types of EDA tools will be dealt with in our future series. I encourage all participants to attend every session, engage actively, and apply what you learn in your academic and professional journey. Your participation will encourage us to organize more such programs which help make students industry ready. I want to take this opportunity to thank all those who supported this program. This program would not have been possible without the encouragement of Sajal Mittal, Chair of CEDA Bangalore chapter, and Vamshi Krishna, Secretary of the chapter. Vamshi has been instrumental in handling all the logistics for this program. I sincerely thank the student volunteers Rakshita from KSIT for preparing all the promotion materials and Dheeraj and his team from BIT for carrying out offline promotion of this event. I also thank the CEDA ExCom members for supporting this program, especially the faculty members who motivated their students to register this for this program. Now it's my privilege to introduce our speaker, Mr. Aloke Das. Aloke is a highly experienced professional with over 28 years of qualitative experience in VLSI design and embedded systems industry. He is the founder and CEO of Lab and Lecture Semiconductor, Bangalore. He is a professor of practice at Atria Institute of Technology, Bangalore, and a guest faculty at New Horizon College of Engineering, Bangalore. Aloke is a senior member of IEEE and served as chair IEEE Circuits and Systems Society, Bangalore chapter in 2025, and as the chair of IEEE Council on Electronic Design Automation, Bangalore chapter in 2024. He is also a fellow of Institute of Engineers, India. From 1997 to 2014, he worked in various product companies in VLSI design industry. He has contributed technically and built teams for processor and system on chips in companies such as Intel, PMC Sierra, Dellsoft, and Dellsoft. From 2024 to 2020, he has contributed technically and built teams for multiple clients in various VLSI design services companies such as Tizol, Savitech, Altran, Black Pepper, and Waferspace. He was the director of engineering in Black Pepper and Waferspace. Aloke holds an MS in physics from University of Calcutta and MEMTech from IIT Delhi. Aloke is an expert in open source EDA tools and has significantly contributed to the open source community. We are truly fortunate to have him lead this program. Now, I would like to mention one important point here. Although this program was primarily designed for students, we also invited faculty members of engineering colleges. We believe that faculty participation can help strengthen teaching in EDA and support research activities and also encourage publications in this area. While we just have one faculty registration this time, I hope this will inspire more faculty members to participate in our future program. So I thank Professor Hitesh Durai of Geetham University for not only participating in this program, but also inspiring a lot of students from his university to register. Once again, I welcome you all and wish you a very enriching and insightful learning experience. Thank you. And before handing the stage to Alok, I request Sajal to speak a few words.
Thank you, Girish. I think thank you for the detailed introduction and format about the event. I won't take much time here, but thank you everyone for registering, first of all, and joining this event. As Girish mentioned, like this is a very important event that we are trying to conduct here because as your technology node is becoming shrinking, EDA tools are very important to have intelligence and help you in designing all those things. So I would ask or would request everyone to leverage this session and please make good use of it. You can provide your feedback so that in future session we'll try to incorporate that. So with that, I don't want to take much time. Thank you, Girish, for coming up with this format and driving this actively from last few months. Thank you, Alok, for agreeing to deliver these lectures, or I would say talks to the students. I think you are well known in the CEDA community as well as the IEEE community. A lot of students knows you, so I don't need to introduce. And thank you, Vamsi and Dheeraj, for driving all this logistics and everything. With that, I think over to you. Nothing much. And sorry, my video is off. My laptop is not supporting me today, so I joined from my mobile. Maybe I'll join in some time with video as well. Thank you, guys.
Okay, thank you, Sajal. We'll have this Q&A session at the end of the session. Is it okay, Alok?
Yes.
Yeah, okay.
That should
And
be fine.
yeah, please type in your questions in the chat box, and I will read out the question at the end of the session, and I will moderate the Q&A session. Alok, over to you. We're all eager to listen to your lecture.
Okay. Thank you. Thank you, Girish, Sajal, and Vamsi. We tried to do this program for a long time, and but this today this came into reality, and I'm really thankful to CEDA Bangalore. And personally, I wanted to do this because I have worked in this field of technology, and I wanted to share my knowledge whatever way. And also the main purpose of this series is to share knowledge and also guide you how to get into this field, means getting a job. That is the main that is the main point of this program, so that you get something, you have invested something, your time, money, and you get some return out of it. Having said that, let me share my screen so that I can present. Okay, is my screen visible?
Yes, it is visible. Yeah.
Okay, great. And I think I should somehow minimize this. Yeah. Okay, we represent CEDA, and from its inception, we have done program which are hands-on in nature, and it delivers different kind of values to our stakeholders, means the members, students, as well as the execom members. So what we are going to talk about is electronic design automation. And what does that mean? It's a branch, it's a multidisciplinary or interdisciplinary area where the software and the electronics, I'm not saying hardware. Basically, hardware means many things. This is only the amalgamation of software and the electronic design, means circuit design mainly. Circuit design with discrete components like capacitor, resistances, and all those things, which serves the board or PCB design. And nowadays, the design on silicon means VLSI design. So I'll be talking about this thing. And the way I'll follow is like every 10-15 minutes, I'll give a pause, maybe for one minute, and because I need to take rest also. And also the main thing is you note down during that point what you want to ask, and you will get enough time for asking those questions, because I'll not be able to answer in 1 minute when I pause there. But I will request you to note down what you want to ask, and later we'll answer all the questions. And also, before the next lecture, means alternate weeks we are doing, and we'll discuss at the beginning also. The regular thing, from 6 to 7:30 will be there. Probably if there is a need, I can join half an hour before, like 5:30, and clear out all the doubts of the previous session. And from 6 o'clock, we'll start the next as usual. And video, I think it is being recorded, but I'll strongly recommend that you guys attend, and do not put it into the back burner. Like there is a video, we'll go and look at it. That doesn't work that effectively, but you are free. We will make it a totally like professional thing. There is nothing like you cannot do that, but a strong recommendation. Listen with me, work along. Having said that, let us start the series. So, electronic design automation software. So, we'll be talking about software, no doubt about it. But what that software is a, what is that? It's a computer is used for all the field, not only engineering, also physics, chemistry, photonics. Everywhere we take help of software, computer and software. Similarly, in circuit design also, we do the same thing. So my voice is clear, and you are able to see me and hear me. Okay.
Yes, we can hear you. Please, yeah.
Okay, great. So what is those softwares basically in VLSI design? In the industry we work, we all the CEDA people work, or the professors who teach in EC. We mainly deal with all these softwares. Many of you may know this or may not know this, but gradually we'll introduce them. One of them, and the first thing, is the compiler and simulator. That is true for the digital also and the analog also. So basically, you write something in textual format, in texts, in word, English words, and then you run a software. That software needs to understand what you have written, what you are trying to convey, what you are trying to do with the circuit. And that portion, that work, that is called compilation. There is a step, and there is a computer science concept called compilers. So people needs to understand, not only in electronics also, plain software like C, C++, Java, all these things. We write in text, English text, and the computer needs to understand what we are trying to convey to the computer. That is a kind of structured language which the words looks like English, but the grammar is more or less like English, but not exactly English. It's a kind of concise form or shortcut of English or something like that. You all know. Uh, so that job is done. Its name is compilation, and the software which does compilation are called compilers. And after that, what we must do, why we are doing this, because when we used to create circuits in breadboard or PCB, we need to see how it is working. So that is not possible for large project or many projects. And so we need to do the results, the circuits, the components we have connected, how they are performing, what is the output, what is the input we are giving, what is the output we are coming out of that circuit. So that is the main purpose of all these things. We need to be sure that whatever we have built or we it will build, that will work before spending any money. Like for discrete, like board, PCBs, we want to assemble all the components in software, and we want to check whether the board will work or not. Similarly, in VLSI design, we want to connect all the transistors and see whether they are connecting, working or not. So that is the simulation. That is very important, and that is the very first job we do. And this is the main and the very old EDA tool that came into market. After that, gradually logic synthesis and technology mapping came up, and that is needed. Synthesis specifically is needed for digital circuits. Analog we don't synthesize because they're all in transistor form only. And after that, there are formal verifications, static timing analysis, or the downstream tools. These are called downstream tools. They are used mainly for digital designs. But compilers and simulators, they are used for analog and digital, all the things. In this lecture series, we will deal with mainly digital circuits and analog, because there is not much automation in analog area. So we'll skip for this series, but there are little bit of that will take later in later set of series, all those things. So this you most of you know, and I'll move to the next one. So what are the tools available in the market? There are three varieties of tools. One is, of course, the commercial tools. There are companies, very well-known companies, very old companies. They sell this kind of softwares basically. And these are Synopsys, Cadence, Siemens, Keysight. They all have the same variety of tools, and same variety of tools, and they sell it. Okay, they sell it, and there are other tools also which are freeware tools. So these tools basically, those who are not so established players in the market, they generally offer them for free. These three or four companies, Synopsys, Cadence, Siemens, Keysight, they are established players. They will never give you the tool free. But there are other tools, companies or startups who are coming up. Like in 10 years, 15 years back, there was a company called Magma Design. So they were startup in that time, and they used to give free tools for use. And the third variety is open source tools. So what are the differences? As you know, commercial tools, they have a big company, big set of developers, researchers, computer science guys, electronics guys, and together they develop, as well as the support. Support is the very important thing, because we are all, most of us in this industry, we are engineers, electronics engineers. We don't know much about software and how the tool works. So that support is very important for us. So these companies are very good in supporting their tools. They will come to you, they will debug sitting next to you your problems, as well as they will suggest the best way to use the tools. And if there is a shortcomings in the tool, you file it as a bug, and they will fix their code and immediately, and they'll help you. All kind of helps you will need, but at a huge cost. Each
Hello?
of these tools. Hello.
Jana.
Okay, so each of these tools are very costly, and you get all these things, good things at a price. Freeware tools are comparable to the commercial tools, but with a limited feature or for limited time. Sometimes they give it for full free feature for 1 month or 2 months, like that, or they can give you for a longer duration, 1 year, with a limited, like Verilog code for 1,000 lines, synthesis with 180 nanometer only. All those restrictions may be there, and sometimes like that, but they are still commercial tools. After this free period is over, they charge it. And both of these tools, freeware and commercial tools, please understand, you have to understand very well, the source code, the software code, that is not available, and you cannot ask them to give it to you. You cannot download, you will not find it anywhere, and you cannot ask also. You don't have that right. That is by law. Freeware and commercial tools. The third variety is the open source tools. These tools are not supported or developed by the companies, commercial companies. They are developed by mostly students and community. Community means the senior guys also are there, senior people like me, and we also develop and give it back to the community, because we know sometimes at some point of time a free tool, totally free tool is needed, and if we give it free, means the source code is available. Somebody who is interested and motivated like that, and believe in the same philosophy, they can download and improve with that hope. Many people do that, many people across world do that, and this is a very good way of contributing to the engineering community. Moving on to the next slide. I thought these slides, this and the next slide was not there initially, but just 1 hour back, I thought that let me add it, because people will have a question, what's in it for me? Why should I get into EDA? Because mostly if you are young and maybe looking for a career, a job, that is everybody is that is perfectly fine, that should be there. So career in EDA, how it looks like. There are two paths in this. One is application engineer, and the second thing is tool developer. So what an application engineer does, they are basically these companies hire them, and one has to know the usage of the tool. You don't have to know how the tool is written or how the internals of the tool, that software code, you don't have to know, but you have to know how the tool can be used. And this knowledge of tool is like company independent, because these will be used by Intel, Qualcomm, SanDisk, and Samsung. Every chip design companies will be using them, and you have to have a like company agnostic knowledge how this tool. So what is the basis? Basically, you have to go through the manual very well, their manual, this company's tool or particular tool you will be supporting, that manual you have to know, and a good amount of design knowledge if you have, then you can be a very good application engineer. Because as you know that designers in those companies, they don't have much knowledge about software. If you can help them and tell them, because they don't have time to read the manual, right? It's a 750 page or 800 page document, and they don't know, and it is not possible also to know each and every feature how they work. So the application engineers bridge this gap. They know how well and what are the intricacies of these tools, and they can help the designers of those companies, and that the debugging customer issues, recommend solutions. The senior application engineers generally recommend solutions, flows, scripts to the companies. That is very helpful and very effective. And in some cases, most of the time it will be the designer's problem, but there are cases that tool has some shortcomings, or it cannot do some things, or new things the customer is trying may not be able to supported by the tool. So in that cases, these application engineers will reproduce this problem that customer is facing, and they will send the test case to the development team of those EDA companies. That is also the second help that is very much needed to improve your tool or add features to your tool. That is a kind of very short. We can discuss more, much more in these two topics later, but in very short, this is the career in EDA application engineer. The tool developer that we will be talking in this series is the developing actual software, writing the software right from the main function in C++. So you need software knowledge, but not like a computer science guys, but to a great extent. I'll not simplify or make it look creative, but yes, you need to know the software. And don't worry, you don't have to know right now, because for my case also, I'm an electronics engineer. I learned the software portion on the job. Whenever I needed, I was stuck, I opened the C++ book, and I just literally went through while sitting in the company how to write this, how to write that, how to write a doubly linked list, how to write a stack, all those data structure. This is things. But while you are into your studies, if you can get some amount of knowledge, you will open up yourself to a great career, dream career. So just think about it, and if you have a like inclination towards software, because many people like software, the electronics engineers also I have seen, they like software development, and it's good to have, because you can have a rewarding career. And knowledge of electronics is needed, because these softwares will be used for circuits only. So develop, enhance, and debug the features means whatever the tool does, you have to develop inside that company if you are hired. Enhance means whatever was there. Basically, mostly the tools are there, right? There is very limited scope to work on a new tool, because the tools are there, everybody is using for last 30-40 years, like that. And nowadays, in my time also, we started new tool development also in Magma. We started developing new tools, and so we are fortunate to write the main function of those kind of tools. But nowadays it's absolutely zero, I think. But there is a lot of scope for enhancement, enhancing the feature, adding new capability and new optimizations and all those things, which are even very like rewarding, very satisfying job. the people who are into EDA tool development career, they say actually it is a very job satisfaction is very high. And debug the feature. When the application engineers send those test cases, you have to debug why the problem is coming, where the shortcomings of the code is there, where the code is failing. So you have to debug and fix those issues. So junior engineers will be put into debug. Gradually, when you get more experience, you will be added to enhance. And maybe if you spend 25, 30 years, some company at that time, if you're lucky, they're thinking to create a new tool, they will call, hey, can you write the main function of my tool like this? So this is the career. Excellent knowledge of C++. Basically, these tools developed almost 30 years ago, started being developed. So still they are written in C++. And there is another advantage from a processor. You get the best speed in C language, but because of the maintainability, C++ is better because it is object oriented. So we either it is written in C or C++. So you have to know the C++, Java, .NET, C#. Those are used in mostly in web development, but engineering software is mostly developed in C++ because we need speed. Because our design is very large, and these tools can run for months. So always we need optimization in the code so that we can finish the job within shorter time. So this is the career looks like. And I'll since we'll be talking about the tool development, so tool developer, how it looks like, why it is so lucrative. It is one of the highest paid jobs in VLSI design industry. So I remember when I was in Intel, and initially I used to develop their DFT solutions. So we had a special package like those we were used to call CAD engineers. So CAD engineers used to get a additional benefit in terms of money. So design engineer salary will and CAD engineer salary is the same designation. CAD engineers will get little bit extra because of their that experience. So that kind of things are there. And in general, in synopsis, those cadence, actually who writes the code, because few of my students are still working in synopsis Bangalore. So I know this thing. This is a very high paid job. Open source tools. Here it comes. Open source tools. Since it is a very high paying job, it is so interview will be little bit tough. Obviously, you can expect that, but no risk, no gain. So how to get into this? The best way is to get into an open source tools. But these are the bridge between you and the dream job in EDA. So what you have to do, take any open source EDA tool and become contributor. So first, it will be difficult, but start from the documentation. Use the tool and improve the documentation. Then gradually get into the code and understand. Once you are familiar with that code, then you can apply to these companies, and I'm sure that you will be able to get through this interview and you'll get your dream job. The second thing is, while you are preparing for your interest, the EDA open source community gets some benefit because of your effort. The tools get little bit improved, the documentation gets a little bit improved. And one of my intention, like what I am trying to get out of this lecture series, this is one of these things. you guys come and contribute to the open source community. I'll pause for 30 seconds here, and yes, and maybe you think what I have just spoken. If something is not clear, you want something to ask, just note it down. I'll not be able to answer now, but definitely today itself, at the end, maybe after 1 hour or whatever I wanted to talk, if I finish it, I'll answer those things. Okay, let's get started. I hope you have noted down your questions, and we want to do it very professionally and in structured way. But believe me, you will get all the answers. So, in this, from today to May, the end of this program, out of all these tools, right? They are all these tools. They are all kind of, I'll be able to not this placement route. It's a little difficult, but till power estimation, I can talk a lot of like hours and hours. But for this series, we'll take compilers and simulators. And when you finish this till May, you will be able to uh, write a compiler. That I can guarantee you. But it will be not like a synopsis VCS compiler, obviously. That is true, but you will know actually what is a compiler, how to write it, and what is there. And if you obviously, if you put more time, you can improve, you can do a lot of things, and more or less you can do what a BCS or model sim can do with a small design. So compilers and simulators, basically, if you see all the compilers, Verilog compilers, basically I'm talking about Verilog or VHDL compilers or similar kind of compilers. I'll talk about that. So all of them, mostly there are two tools, but we see only one, like VCS, Model Sim, because they package these two tools together, and it has been from the beginning always. Sometimes in cadence it was little bit, three tools were there, one vcom or something, vmap. There was three tools differently, but now everything is merged, only one tool. But you will never see that compilers and STA tool, DFT tool merged. No, they are separate tools. But compilers and simulators are together one tool, because they are interlinked very tightly. So compilers has to compile, and simulators is not compilation. It is simulating the design. If you give some stimulus, then you should be able to see what is the output. So that is the simulator. So any compilers means compilers and simulator. Always you have to know. If somebody is saying we have a Verilog compiler, that means it has the compiler as well as some kind of simulation support. So these are the two distinct tools, and algorithms, codes, everything is very different. Very different. Compilers and simulator codes are very different, but they come always in one package. So compiler, what they have: command line parsing, language parsing, and create design tree. We'll discuss about all these things. And simulator is basically what applies stimulus. That is very interesting to us. Traverse the design tree. The whole design we have to go through those stimulus from input. They have to traverse, they have to travel from the input to output, and they will get transformed based on the logic in between, and something, a new value will come in the output, and we have to know. We are interested in that because we'll not spend money in manufacturing those things, manufacturing the circuit before I know that my design works. And obviously this traversing and design, what I've just said, its main purpose is to calculate values, nothing else. Very simple. So input of AND gate or gate, there will be input values. I want to know the output values, and that's how from output to input to output, output to input, output to input, like that. It will go simple task. But when it is done in a large circuit, it becomes complicated. And the second complication, one is accuracy, which can be handled because these calculations are like class 10, not even class 10 calculations. So logic value calculation is very, very easy. There is nothing like Fourier transform, Laplace transform, Hermite polynomial. No, nothing like that. It is just arithmetic calculations. And very easy, but the time taken to traverse this design and justify these values is a concern. And there are computer science techniques we apply to get it done in a very shorter time, in a very efficient way. And there are other things we'll see later. So these are basically two things we'll be talking about throughout this series. The example of compilers as well as simulators, of course, System Verilog, PHDL, Liberty, ALF, System RDL, IPExact, all these things. So these are hardcore languages, System Verilog, like C, C++, Java, PHDL. They are hardcore, like large language, large keywords, large number of keywords, large grammar, all those things. Liberty, ALF, ALF, these are all technology library formats. So these are little bit easier than System Verilog or VSDL, and but still complicated grammar. System RDL, IPExact, not very popular, but very particular for niche area. It is used. Power format is very simple format. It is not complicated. So sometimes we use scripts only, not a compiler for power formats or timing constraints, DFT formats. Or sometimes we don't need a compiler, because if the input file, the grammar is simple, then we may not go for writing a compiler, but we may also. That doesn't matter. And when you learn how to write a compiler, you will be tempted. Okay, let's write a compiler. I can write it in 2 days, no problem. That will become fun for you, and you may go for writing a compiler for that. So these are what basically what these things are they are languages. What I told in the beginning, they are something written in English like language, and you are trying to convey some electronics phenomenon through these text files. And for that, compilers is the computer science way to handle and convey the message to the computer, and after that only you can do the other performance, other jobs. So this is the basically compilers. And so we are taking compilers first, then we'll move to simulators later. First, initial half of the series will complete first compilers, then we'll go to the simulators later. So now, what is there in the compilers? So now compilers have these 5 jobs to do, basically, that software. So maybe not all of them are mandatory, like graphic user interface, it is nice to have. Message handler, it's nice to have, but these first 3 is the basic core things there. And first, command line parsing also may not be that important, but this middle 2, language parsing and design tree creation, these 2 are the core part. And command line parsing is very desirable. I'll not say nice to have, it is desirable, very recommended, but not the core part of a compiler. And message handler, nice, more than important, more than important to have, like nice to have. And graphic user interface is not a core part, it's a nice to have feature. This basically, this 5 portions will be there. So in a compiler, if you see the compiler, any compiler, you will see this 5 major portions of the software. And when you join Synopsys or Cadence as a developer, you will be assigned one of these areas, and this itself is a huge area of interest, area of work, all these things. So lot of scope. So I'm dividing all the tools, then I'm taking compilers and simulators, then I have separated the simulators out. Now in compilers, I'm again peeling the onion, and we are getting the facts right now. So now in this, the first half, I'll show you how to write all these 5 portions, but very smaller form. Okay, so that I can get you started, and when you go back, you can improve, add more, so that it can become a full-fledged your personal compiler. And if you choose to write Verilog compiler, then it will be your Verilog compiler. And VSDL mostly nobody uses, at least in India and US. VSDL is not used. Only Europe and few universities use VSDL. So we'll concentrate in Verilog only. So the first topic, right? Command line parsing. What is that? Command line. What is command line? See, in our life, in VLSI design engineers' life, and earlier when I started, like 25 years or 30 years ago, and there are, even Linux was not GUI. It used to be a black and white terminal, like TV screen with black and white, with black background and white letters. That's how we started. So Linux is like that, and all the scientific softwares used to be like that only, mechanical, CAD CAM, everything, and analog like spice we used to simulate like this only. There was no GUI, no waveform like that. From the output we used to understand. So that was the thing. And still more or less the life is like that only still today. And command line means this is the line. We don't have anything to click, double click a button to get results. No, most of the software still, I told that the commercial software, Cadence, Synopsys, they have nice GUI. There is a possibility of clicking something, and many people have started doing that thing, but mostly this is how the tools are run in VLSI design. This is line, this is command prompt. We write the tool name and simply press enter. So that is called command line interface, CLI, command line interface. So I have a compiler installed. I'll show you later, which is called iVerilog. This is equivalent to VCS. This is a Verilog and VSTL compiler and simulator. In open source world, this is the kind of polar star. Like we only use this thing, and we have done a lot of tape outs also using this thing. It is obviously, I cannot claim that it is great and this and that equivalent to VCS. No, it is not, but it can do the job to a great extent, and many people are putting their effort to improve this more and more. And also I can proudly say I also try to contribute that, and I have contributed to this. So this is called command line, and when you run this thing, only the software, this is called executable in computer science language. This iVerilog is the executable, that is the software that we are trying to write. And when you run, it will give you this kind of messages, right? iVerilog, no source files, usage, something. So something comes out whenever you run an executable. It runs on the processor. It processes something, and based on whatever the other input you have given, that comes out in your, which is called, this is std out, means your output screen. And generally this is called usage. If something, the tool is not called properly with proper things after that, then it should give the usage. See, it is not any magic. Somebody has written this code, somebody has written the code to analyze that nothing is there after the executable. So that's why it is giving some message, and it is showing this is how this software should be used. So this is called command line parsing, and some kind of message handling. Here I have said message handler. Later you will get more flavor of it. So something, you have to do the things, also you have to convey the user. If something is wrong, then what is wrong, so that guy understands what mistake he has done. The software which does very good in that software sells very good, and commercial softwares are very good in that, so they sell very good. The open source people, they don't have time, because they are like us, we have a day job. On top of that, we do some, we see that okay, no problem, message will deal with later, let me implement the core functionality. And in this thing, sometime after sometimes I'll get more busy, and that message handler will not be written, and the tool, everybody will complain that it's a bad tool, nothing able, it is not able to understand all those things. But this is the scenario. So everything has a importance. So this is the message handling. So how to call the tool? Um, don't pay too much attention because this is the design thing. But what essentially I'm trying to show here, if you call this software with other things, see how many things are there. I'll explain it later. Then it is not giving this message. Basically, this is error message. It is not giving any error messages, and it is compiling correctly. Okay, with some, this is called warning, constant selects, blah blah blah, some message it has come out, but it ran properly. So this, from here to here, this is called command line. The whole thing is command line. The first one is the software, and other things are other necessary things. So why it is needed? Basically, for example, we are writing a compiler to compile a Verilog file. So that software needs to be uh, flexible. Like if I want to compile pwm.v, it should compile. If I want to compile this, it should compile, or any other file. So you have to write, you cannot hard code the file name inside the software. When we are into college, undergrad, we write software programs. But sometimes to save time or simplicity, we hard code the input file name, we hard code it inside the code, so that it can compile only pwm.v. If we want to compile other things, then we have to open the file, change the file name of the input file, again make the executable, then only. So but when you are selling software, there is no scope. So you have to make the software in such a flexible way that the users can navigate or guide the software, do whatever you want. The way of the technique to do that is the options. These are called options. Guiding, you are guiding this software with these options to achieve something else. If you don't use this software will do something else. If you use this thing, it will do something other. So you are guiding the software because you have bought it or downloaded from some other persons. Now you cannot open the C++ code. Hello, is there? Okay, so you don't have the flexibility to open the C++ code, and so whoever has written this software, he should written in a flexible manner so that the users can use it in many different ways. So this is the way, and this is the technique called command line parsing. So before the parsing the language itself, the software has to know what are these options, and it has to parse these things. This is called command line parsing. Understanding what is associated with the how the software is called with what all options. So this is called command line parsing, and we'll show how to do that. So this is the main function of this Verilog compilers. Okay. So see, int main, int argc, char star argv. So most of us, we have read C++, at least C, We know we have written many times this main function, but most of the time what we do, int main, then open bracket, close bracket, int argc argv. 99% time we don't use it, and we don't know also what is the significance of this. Those who know, I really congratulate them, and great, you should know this. So this is the thing, when you call this kind of the software with this thing, then these two arguments get some value. What are the values? I'll tell you later. And based on these two arguments, when in C, C++, these are called arguments. So in these arguments gets here, and there are this option, they are using this function on these two important arguments, and they are getting something, and after that there is a switch statement, and this based on this opt is a soft form for options, and for h it is writing the help. So the help, what we are getting here, these things. So this is the some kind of help they are trying to write. And what about the others? Case I, if the option is I, then do this. If option is L, do this. Option is M, do this. So with the switch and case statement, and by this options functioning like command line parsing function, you get the options separated out, and based on the each case values, you are taking different actions. So your software is now become flexible, and now you can do different things by supplying different options to the same executable. That is called command line parsing. So main function is the starting point of C++. Okay. So the argument argc and argv are the key technique to get the command line and these things. So the extra letters and words, what are those extra letters and words? See, extra letters and words, these are called options or file names, like this spi.v timer, all are Verilog files with some designs. So these options, this command line can have options, file names, configuration file, and compiler directive defines. Means this one minus d dump vcd means I'm saying that after simulation, write the simulation results in vcd format. Those who know, vcd is a format to visualize in any of the simulator GUI. So this is minus d is used for compiler directives. We'll explain later, don't worry about it. So there are, what I'm saying is, there could be many switches which can turn on and off of the software by using command line, and there is nothing, no magic. You have to have the code, command line parsing code, to effectively accept all those options and take relevant actions. This is called command line parsing. This is what happens. The moment I call the executable with these many, like G 2009, blah, 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 then what happens? This end argc argv, right? We have called the main function with this thing. This argv automatically from operating systems, this is the job of operating system, will assign this array argv and each of the element will get the values of these command lines. See, I Verilog. So zeroth element means the first element will contain the name of the executable from 1 to n argc minus 1. That will contain the other values, other letters, characters, or whatever, minus, everything will be stored separated by space, by default separated by space. If there is a space, then the whole thing will become an element of this argv array. And how many elements are there? That will be, yeah, argc minus 1. That's why we have used argc. So C++ has this kind of arrangement um, for the operating system, gives this benefit or arrangement to the C++ compiler, and most of the other compilers also. Java also, there will be main functions like that. Most of these languages will have this facility. So int argc main int argc is the key thing for the command line parsing. I'll stop here, and whoever has noted the questions, I'm ready to answer right now. But give me 30 seconds. I have to take a call basically, and you can just prepare yourself with the questions. I'll come back after 30 seconds or 1 minute. Girish, over to you.
Yes, actually there is just one question here. I see that person say, the student says, I want to create my own Verilog compiler.
Yeah,
This
definitely,
statement, yeah,
definitely.
yeah.
This series is for that only. But you can ask more, like if you want to elaborate your question, just feel free. And but give me 1 minute, just one
Yeah.
minute. I'll come back and answer you.
Kamlesh, you can type your question if you have, if you want to ask more.
Dear participants, if you have any questions or comments about this program, please post it in the chat box.
And Aloke has offered to add extra half an hour to this session from next week, from next session. So if you have any questions, please make use of it. It could be for anything, not only asking questions if you want. Anyway, as a part of this course, you also have to execute a project. You can ask for suggestions or anything related to EDA.
Girish sir, we are having one question in the chat.
Yeah. Once he returns, I'll read it. Yeah, there are a couple of questions.
Yes, I'm back.
Yeah, okay. There are some couple of few questions. I'll just read them out. Will we be able to build compilers for RF tools as well? Also, if GUI would be possible. And do we need to know Spice code for design analog based compiler?
Okay, so the question is Spice, right?
Yeah, first part is that we'll be able to build a compiler for RF tools.
See, there is nothing like RF tools. Okay, so RF is a kind of circuits, and that can be RF circuits can be designed through analog tools. So analog tools are like Spice, ngSpice, HSpice. That is, of course, that is another type of compiler. But in these, we will not cover that thing. But you will know the technique. You can create any type of compiler.
Actually, more than compiler, I think for analog, we can write a simulator just like Verilog A or Verilog AMS. We can't synthesize a code, but only we can simulate a circuit.
Yes, but still the Spice is a language like Verilog. Okay, so that language has to be compiled, and again after compilation they can simulate. That is also written in the similar way like Verilog is done. So I'll show the common way so that they can write any of those things like Liberty. Liberty is the technology mapping language. Then system RDL, that is a memory or register creation language. Any language create, they can write compiler. They will be able to write compiler and simulator for that.
So then they need to know Spice for that?
No.
Okay.
That is the thing.
Okay.
They need to see. This is a tool development. They need to know, but not like a circuit designer. They need to know the language, the keywords, what is the grammar. I'll come to that thing. Obviously, without knowing the language, they will not be able to create the compiler, but the knowledge is not like a circuit designer. Designer knows what is the implication of using this transistor with that transistor, what is a current mirror, and all those knowledges are not needed. But what is Spice, what are the keywords, grammar, those things are needed.
Okay, thank you. Next question is, I heard designing a compilers are very difficult job. Can we build a compiler within like 6 to 7 sessions?
Yes, that's what I'm trying to do that actually.
Okay.
But you are also right. It's very difficult, but very difficult for what? To write the complete Verilog compiler. Complete in all respects. Yes, that is difficult. But you will know, maybe Verilog has 100 features. But I can show you in this 7 or 8 sessions how to create a compiler for 5 features. And you can extrapolate that knowledge to develop yourself and complete it later for all the features.
That's very interesting and also inspiring actually. And what are open source tools which we can access to learn from the starting point?
Okay, good, great questions. So one is iVerilog. Let me share my this thing screen again. Uh, so this is the landmark or like flagship open source, and you can get the source code and try to get into like read or look into this. And believe me, you will be frustrated first time, but don't, because you are starting, so don't get deserted. Put 1 hour at least. If you don't even understand, just look again. One day you will understand, and we'll create some kind of group or something so that we can discuss all these things. But you can understand, right? It's a very big code, difficult to understand, but nothing is impossible. So if you try to get something done, you spend time and build over the time. And here you can get all the source code. There will be tar zip files, okay, and you can 7z, these are the zip files. If you unzip it, you will get the whole code, C++, and whatever is there in that thing, you can get it and you can look at the code. The other thing is um, github.com yes, this is my GitHub, and generally I create softwares, EDA tools here, and I keep it, upload it here, and it is accessible. This is open source. I have made all my tools open source, and here is a compiler which is not a Verilog, IP exact. I hope all of you are able to see. This is my GitHub. I'll type it in the chat box also. So IP exact. This compiler is created by me. RDL parser. If you go inside this and this front end directory, this is nicely. This is a small parser. This is language is also small, and you can see how I have created this compiler. Here somewhere we will get the main function mn. Yeah, this is my main.cpp. If you see, you will get interesting. See, this is a small main function, but it has some other things also. Then it has a yak file. This is bison, this is flex file. I'll explain all those things, how to parse the grammar of a language. This is small, so you can download means git cloning, git clone it is called. So git clone, if you do, you will get this thing and you can look at it. This is a nice small compiler, and you can look at it. Otherwise, standard large compiler is that one, Icarus Verilog, that I have already shared.
Alok, I think your compiler could be a good starting point, because since you have written and people, students will start reading it and ask you questions first hand, so that they'll get a very clear idea of how the compiler.
Definitely.
Yeah. So
in my lecture also, I'll give some examples from there itself.
Okay.
So that they can do.
Yeah.
Yes. Next question, Girish.
Next question is, what type of projects need to be done in this workshop?
Simple. Create a compiler. And if you're more enthusiastic, if you have more time, you can add a simulator also, because I'll show how to write a simulator also. It's not easy, it's not difficult either. I can say you just believe in yourself, not myself. You can believe myself also, but believe in yourself. Somebody has written, you can do it.
Okay. The next question is, could you recommend some open source EDA tools? When you said improving documentation of tools, what components of the tools are we trying to improve?
All sorts of. First of all, see, whenever you, for example, this Icarus Verilog, okay, and for all my tools also, I have many in my GitHub. There are many tools, not compilers. You can see iSynth, iLint, and all those things. You can create documentation. But if you, I would recommend get into iVerilog. And first thing they ask, right, improve their documentation. Just read their existing documentation, try to run the tool as it is written, and if you see the documentation, there is some problem, it is not complete, add to that only. That the community, we value that thing. See, don't think that documentation, it is not core job, but that is very valuable thing. And open source community needs good documentation, so you can add whatever you can in the documentation. Later get into the code, and all sorts of, after that, all sorts of like command line parsing, all those options I showed, right? There are in that usage, lot of options are there. Each of the option, what they do, what is their function, if you use, what will happen, those are the documentation. Command line parsing, then message handler, the lot of messages comes out of any EDA tool. We don't have time, right? We have day of job, we just write, this is not good, that is not broken, this kind of, which is kind of cryptic language. If you can just flag it, like I'm not able to understand this language, or this scripting message means this is the problem. If you can elaborate that, that is a great help for open source community.
So documentation is always an issue with the software tools, whether it's open source or even commercial tools.
So that is a great help. And like I have said, for a compiler, there is command line parsing, there is a section, then core parser, then data structure, design tree creation, then message handler, then GUI. iVerilog has little bit of GUI support. You can make documentation, and there is a great scope to add GUI. I'll tell you how to add a GUI support to any tool, any tool. Graphic, those nice buttons and boxes, how to create, I'll show. If you can add those things or whatever support is there, you can improve on that. That will be great help. Yeah, I think Lakshman
Yeah,
raised hand.
we have few more questions, then we'll come back to Lakshman. Is okay?
Okay, okay, sure.
Yeah. If we can mention some open source tools available for the participants to explore hand in hand, would be helpful and more interesting in trying the things being lectured by Professor Aloke.
Definitely, but I would say one is Icarus Verilog, that I seriously want people to support. So, but I would recommend, but if you want to do it, you can start right now. Finish this series, then get into that. After you finish this series, no, you will be able to understand the code also little bit. At least what is a lex file, what is a yuck file, what is there written inside that. You will be able to at least understand. Oh, okay, sir told like this portion is for that feature. Then you can, this Icarus Verilog itself, and if you are familiar, if you get familiar, if you like it, then there is another set of tools which is like in news, or where people are very interested, is open road means all of those tools, compiler, synthesis tool, EOSIS, synthesis EOSIS, STA, open STA tool, then NetGen for LBS. There are a hell lot of, like 28 tools are there for chip designing. All of them are open source, and they need serious developers and serious help. I can give you 28 names, but if you want, next day I will give it, or just wait for this lecture to finish.
Okay. Next question. I am a student of third year electrical engineering with not much exposure to programming. Please do mention what prerequisites are needed for next class programming wise, so that we can make better use of the time between classes.
Great. Very good question. So C language, C++, if you can get some knowledge about C++, that will be great. Even if you, I hope C at least people know. And we stop in, most of us also, like in the senior guys also, we stop at pointers. When pointer starts, then we say, oh, okay, not my cup of tea. Go beyond pointers. There the fun starts of that language, C++. Beyond pointers, then you can handle the data. You can manipulate data. You can corrupt, fix everything. Then you will become a pro. Maybe it is in 7 or 8 chapter is a pointer, and you just see how to create a linked list or something, and then you leave it. Go beyond that. Any book, Strauss Stube, not needed. Some other good book, anything is needed. Go beyond pointers. On beyond pointer, what happens? There will be data structures.
Vamshi, should we inform him or?
Yes, sir. I'm gonna call Aloke sir. Maybe network issue.
Yeah.
I think it's his laptop got discharged, showing low battery.
Yeah, possible.
Possibility is there. Sir, you are muted, sir. Aloke sir. Alok, you're on mute. Yes, not
Yeah.
something.
Okay. So yes. So what I was saying that if you go beyond pointer, there will be chapter on data structure and file handling. How to read file. What is a file pointer? All these things. After pointer, finish till the end. And if you can get something done on C++, what is C++? Just that object orientation, if you know, like base class and derived class, child, inheritance, train functions, those I'll be using in this series itself a lot, because without them it will be difficult to create the design tree.
Okay. If possible, kindly share some resource materials like books, so that we will learn from beginning as student in compiler and simulator design.
Okay, sure. I'll send something to you, Girish, and you can communicate.
Yeah, yeah. Next one is repeat question, I think. Okay, then okay. How do you compare a compiler whether it's better than the other? What are the factors one tried to implement during creation?
Okay. Um, Good question, I would say. First thing is completeness is most like, suppose I'm a designer also, right? I design VLSI circuits, I tip out. The first thing I do, I create a Verilog file, and I compile it. The Icarus Verilog. See what happens. The 1365 IEEE 1365 standard of Verilog and system Verilog is vast. Like, it is a 700 pages of document of the language. The standard, the language itself is 700 pages. So difficult to read for a single people or group of people, but somehow I need a completeness. Suppose what happens, it is not possible for an open source tool to support all the features of system Verilog. Fine, but you have to make your parser complete, and you have to, the compiler will not be surprised by all the keywords I will be using. If you are not supporting, just gracefully give a message that it is not supported till now. So this is how I compare with compilers with others. You may not support because there is a constraint. Maybe if you are a paid company also, maybe okay, fine, but give a meaningful message. If you are not supporting any of the keywords means the feature, each keyword implements one kind of feature of VLSI design. So I'll compare on that. And the second thing is speed. That is little difficult or involved topic. How to optimize C++ code? What are the optimization techniques? We will take later, and maybe handling, basically that comes on handling large design. So AMD processor, like last project, mine project was 149 tiles were there, means blocks. Each blocks could have 10, 15 Verilog files. So it is a 2500 kind of Verilog files, maybe. So many compilers will not be able to handle that large amount of Verilog code. That is another aspect. How the compiler can handle large files, large project.
Okay. Next question. Could you recommend some analog open source tools?
Obviously, I'll write it down. Yes, definitely.
Okay.
I want people to start designing analog, and RF is very good. And I'll
Okay.
where is the,
Okay. There are a few more questions. Shall I read out?
yeah, sure,
Yeah.
sure.
Sir, by end of this series, what can we expect from ourselves? Like what skills we will acquire by the end?
Sir, I guess Aloke sir got stuck again.
Yeah, please once more, Girish.
Okay. Sir, by the end of this series, what can we expect from ourselves? Like what skills we will acquire by the end?
Good. So what I told in the beginning also. So you will be able to write a baby compiler and a baby simulator with few features of Verilog code supported. And you will be able to enhance. You will be confident that you can enhance, add more feature to that. And you will be involved in supporting or improving one or the other open source tools. Mainly, I'm looking for Verilog because I'm talking about only compilers. So, open source compilers means Icarus Verilog. So, I'll be onboarding whoever is interested into iVerilog support.
Okay. Next question. I want to know about some EDA tools which are free and all the components available so that we can build some circuits.
Okay, so for digital, iVerilog is the compiler, and there are other tools also. Gradually, I'll tell. Otherwise, no, people get see. Basically, synthesis for synthesis it is EOSys. For timing, it is OpenSTA. For LVS, it is NetGen. For place and route, QRouter. But I'm sure you'll forget it. But let's go one by one. Otherwise, if then you can write me. If you are an advanced student, I can give you the names. I can give you the names, but send me an email. I'll send you all the name of all the standard that still today I'm using for my, and they are production worthy. I mean, you can tape out with that. I can give you the list. But for this series, I'm looking for only Icarus Verilog, that has most of the supports that are needed for a medium to complex design.
So iVerilog is the starting point, you can say.
Digital.
Yeah.
And for analog, there's a nice tool that is also free and supported by Texas Instrument, that is LT Spice, that I was going to write but got knocked off. LT Spice.
Okay. Next question. Actually, in order to create a circuit which is new and we don't know whether it will work or not, so in that case, if I get some software where all the boards, sensors and all components are available, so I can try it with software before moving forward to hardware, which is free of cost.
I can, in one word, I can give you name of the tool, which is called KiCad. KICAD. KiCad is the tool for analog as well as board PCB design, and you can have standard components there, uh, which is kind of, you can rely on that. Those are not real components, but it is good to start.
I think LT Spice also can be used, right? For some, because whatever provided by Texas Instruments, those components can be used in LT Spice.
Yes, correct.
For proof
Those,
of concept, that should be sufficient, actually.
I think that should be
Mm.
sufficient.
Yeah.
Yes. And both of these tools are well supported.
Yeah.
Known. Yes, true.
Yeah. And Lakshmanan, you can ask the question. You can unmute yourself.
Yeah, you're able to see me. Good evening, all of you. It is a nice start, Alok. Wonderful. So I just want to add a couple of complementary information. So it's, I think, correct me if I'm wrong, LT Spice is analog devices tool. TI Tina is the TI's and P-Spice for TI. These both are TI specific tools, but all three are available for you for free. Can download and use them. Yes, I mean, they are very powerful, quite powerful. And briefly, I mean, there was a question when I raised my hand. You were discussing about the documentation. Just from my experience, uh, I cannot emphasize more than what has been already talked about by Alok about documentation. You will know. Actually, there used to be time when I did my masters in IISc. Yeah, our professors used to tell, like, even if you even if you're dreaming in the night in a room, if you want to dribble something, you don't even know whether it is from your lessons or something else, take a A4 sheet, dribble, and then file it. Okay. This is what we used to be sensitized about. So you won't realize the importance of documentation much until you get 5 to 10 years experience into the industry, whether it's related to patenting subsequently, you want to publish a paper subsequently, right? What you will also realize is when you write down what you have done, you will realize how much more you don't know. Or when I write down, I don't know how much more. We have done
Exactly.
experiments, we have done things. You know, oh, these are the things I'm not able to explain well. So I will go and read again or do more experiments or try more. So it will only keep on enhancing. And the most important thing is when you have, it's not just about software tools, right? Whether you are doing circuit design, whatever kind of practical experiments you're doing, even if you're just reading a paper, your personal notes uh, and documentation is something that will come back to help you after 10 years, 20 years, 30 years. You cannot remember everything on top of your head. Yes, the basic concepts will be, but the details will be forgotten. And you cannot go back to read the paper again fully sometimes. These are very, very helpful. That's what I would like to say. Thanks a lot, Alok and Girish.
Okay, thank you, Lakshman, for that. Alok, you may continue.
So that's what I was planning today.
Mm.
And as I told, I wanted to tell one more thing. So today, since there was an introduction and other things were there, from next, I think those will be minimum, and we'll devote fully on that. And that day, I'll I'll start writing the code during this lecture only. There will be PPTs also, and I'll show how to write. Today I just showed the main function, but actually during this thing I'll create a compiler actually, or at least the structure, and I'll compile. It is not only C++, it is much more things. Like whenever you write like VI, right? In industry also. Like we do projects in Intel, AMD, all these things. There are junior engineers. You have to write a Verilog file, right? You have to open a VI, VIM, GVim. So all those are needed. Those are also experience. Without that, you cannot work actually. So I'll show the participant can see what else they need to know, because something those are so, I mean, blended in our daily work life that I may forget to mention GVim, but that is also needed. How to open GVim, how to work in GVim, all these things which will not be covered in this lecture, but they need to know. And they why how when I work, they will get to know, Are sir opened this thing, what is that thing? Then they will question, and I'll tell this is another one you have to do. Then after saving the file, you have to compile the C++ file, right? What are the compilers available for C++? Forget about Verilog compiler, right? That will come later. But to create the Verilog compiler, you have to compile your C++ code with your by a C++ compiler first. What are those compilers? GCC, G++. Like that, I'll be using that thing in front of them. How to compile multi-file projects. What is a make file? How to create a make file? And what is the benefit of a make file? All those things will come, which is not electronics, not EDA. Those are the things are used every not only EDA development, also all phases of VLSI design. That will be so when I work along this lecture, then people will get more benefit and they'll be interesting for them. For that they need I have mentioned in LinkedIn also, Linux, some kind of Linux. There are 3 ways I have mentioned in the LinkedIn also. Just search in the Google, you will get lot of videos how to install, how to this thing, and I'll show one of those things here, my Linux terminal, and we'll work along. You can follow only the lectures, that is also fine. If you want to work with me, that is also fine, no issues, and we'll do that. That's
Yeah.
all from my side, Girish.
Yeah, I just couple of questions here, and even I wanted to ask that. What should we install before joining the next session?
um, so any kind of Linux system, so there could be three ways. You have a Linux desktop or laptop. The laptop itself can have, many laptop comes with Ubuntu installed, that is perfect fine. If you have Macbook is Linux. Macbook, you don't need to install Linux, because Macbook, the Mac OS is a flavor of Linux, so that is perfectly fine. If you have Chromebook is, the operating system is Chrome OS, but Chrome OS is a flavor of Linux, you don't need to install Linux. Those are by default Linux. The question is, most of us has Windows. If you have Windows, then there are two ways. If you have older than Windows 10, then there are only one way, is VirtualBox or virtual machine, some kind of vPlay or Oracle VirtualBox. You have to install one software, and on top of that you have to install Ubuntu. Ubuntu is the freely available Linux. On that, all the videos, how to do all these things, both the softwares, videos are there. I'll not waste time by showing the installation here, and that is one way. The If you have Windows 10 or 11, some service pack, you can install, enable, basically it is already installed, enable WSL, Windows Subsystem for Linux. Then in Windows you can open a Linux window, and that will work as a Linux. The other option is same, like even if you have Windows 10, 11, you may not go take the route of WSL. You can just install Oracle VirtualBox and Ubuntu on that, and then when we work along, you will face some issues, and also that I'll be able to help you, no problem. But this installation, um, it'd be good if they can do it by themselves before next class. Any kind of Linux, because people have to work on Linux. All the VLSI design industry works on Linux.
Should they install iVerilog also or not required?
Not required. I'll tell them right,
Okay.
and that.
And Git comes with Linux, I think, right? Git is already installed, right?
No issues. I
Mhm,
mean,
not
whatever is not installed,
required.
I'll tell them
Okay.
how to install them. Very easy.
Okay. There is one general question. Where do you see AI reshaping EDA workflows for next generation hardware designers?
Yes. So see, I'll just briefly. It's a big discussion, but briefly I'll tell. AI is another software tool. Okay, when this cadence synopsis was not there, people used to have hard time designing bigger circuits. Then somebody came with software techniques. They created compilers and all those things. That time, 30 years ago, we used to tell, oh, this is a big thing. All the jobs will go. This tool will take all the jobs of the electronics engineer. No. So AI is another tool. AI will be implemented inside EDA tools, because we want to do more job in lesser time. AI exactly does that. So intelligence we can say, but intelligent people what? Like I can think that no, I will not give this lecture. But human beings will not create anything which is like kind of emotional. It may think that no, I'll not compile. So AI will not do those kind of things. AI is just a better software technique, and it will be implemented inside, already getting implemented inside the tools, and tools will work much faster, more accurately. That is our goal only. So that by that way, we can do more chip designs, more chips will come out.
Okay, two more questions. I think already have been answered, but I'll just read out the questions. Will the coming sessions include hands-on session with the tools?
Yes,
Yes.
definitely.
Yeah. And would Windows subsystem for Linux would work for this? Yes.
Yes, definitely.
And that's all I can see the questions. I have a couple of things to ask regarding this one. I wanted to add a few things. Would the technique like learning how to write flowcharts, pseudocode, all those things would be helpful while delivering the project?
Yes, definitely, definitely. Like, see, at least, everything is fine. So people are interested if they finally cannot write a code, C++ code, or cannot make it compile or work. Those pseudocodes, at least will be able to understand that the person has thought through the process. So flowchart is also fine, but if you at least can write some C++ code which can be compiled and which works very
Yeah.
good.
Yeah, fine. Contribute to the open source. Yeah, learning C++. Yeah, you told about learning C and C++. Tool installation you told, yeah. And okay, fine. And group for discussion, we have one participation WhatsApp group. There should be enough, or we should have a Slack group or something. Do you have any experience with those things?
No, anything is fine.
WhatsApp should be fine, right? If they want to
Uh,
ask, they can ask the question there, and we can include
correct,
you also. Yeah.
correct, correct.
Yeah. Yeah, thank you, Alok, for this wonderful session, and it was very inspiring and insightful. Even I learned a lot, and we are looking for more in coming sessions.
Definitely,
Yeah,
definitely.
I think
And
there are no more questions. Yeah, if they have questions, they will just share them in the WhatsApp group, and we can address them later.
definitely,
Uh,
definitely.
Sir, before leaving, I request everyone to switch on camera for a group photo. Request all the participants to switch on your camera for a group photo. Okay, thank you guys. On the count of 3, 2, 1, please give a smile. Let me take one more. Just a minute. Yeah, on the count of 3, 2, 1, one more smile. Thank you guys for attending today's first episode tutorial of the IEEE CEDA EDA Toolsmith. Girish sir, anything to add or we can close it?
Yeah, I'm done. I don't have anything to add. And yeah, please remember to join after 2 weeks. And if you need extra hours, Alok is ready to offer. He's ready to log in at 5:30, and you can come with your questions and we can discuss.
And also, guys, I have added Aloke sir in the participants group, and participants also can now send messages in the group. Please feel free to ask your questions, doubts, or any queries there. Okay, guys. Thank you. Good night. Happy weekend.
Thank you. Yeah. Good night.
Thank you.
Yeah.